Hello everybody. Today we are going to discuss about how to develop a GNuplot throughput graph from NS2 trace files. So to do that, first of all, we should have our NS2, our NAME, and our GNuplot already installed in our operating system. As far as I know, if you are using the Ubuntu, this one, which we are generally all of us using, the researchers of my group, and therefore this is already installed, so you don't need that to be installed here. So let's have step one, that we want to create a trace file and then awk file and then plot files. So to do these things, so step one is to have a TCL file ready, running the topology and the traffic model. Step two is to actually generate the trace files and then extract the events. Then the third step is to run the awk files on the TR files or trace files and extract exactly the items which we want to plot the graph, like throughput or jitter or any other parameter. And the final one is to plot the graphs using GNuplot. So this is what we are going to cover today in this tutorial. So let's start. So first and foremost thing what we have to do is we should have a ready TCL file. List down the TCL file. So we have few TCL files here. We have with us TCP first. So this is what I have discussed in my previous video as well. So this is just a brief about the TCL file. We have queue parameters and then the node configurations, right? So we have 7 nodes working on the 802.11 and AODV protocols and basic node configuration. Here the important aspect of our focus is 002 TCP.tr and followed by 002 TCP name, right? So these are the two files which will be generated as an output file. Here we are considering 802.11g. We are observing we can set this parameters as per our requirement. There are many options like N, AC, a lot of variants. You can check the standard. And after generating the node and configuring it, we are actually trying to generate the traffic. So we would like to just make a small modification here at suppose 10 we are starting to move. So instead of that we will start moving it at 2. So once we have done this modification, we have the TCP agent with the sync and the FTP. Most of them are starting at 10 second and ending by before 100 second, that is 98 or 90 or something. So these are some of the agents we have created, and we are generating the traffic using this code, and then we start the terminal. So here we would like to run NS2 TCP.tcl. It will get executed and it will be generating the name file. So let us have a look at the name file. .name. So we have TCP and UDP both, 002.tcp.tr, and we want to have a look at it. So once we run it, we have it in front of us. This is the event first column. Second column is the time, and our focus is here, which is the level. Thereafter, we are also focusing on the type of packet and the size of packet. So these are our focus out of all other parameters. The details of the trace file format can be observed by simply searching the formats of the trace file, right? So you can look at it in the, if you simply search the NS2 trace file formats, you will be able to get it. This is the one which indicates very clearly the event time, node ID, trace level, reason, packet unique ID, payload, and packet size. So this is just the range of it, the trace file format. You can have a look at your own convenience. After this, what we want to do is extracting the throughput. To do that, what we have to do is we have to use the awk scripts. So let's have a look at the awk scripts first, what we want to write. For us, let us have a look at our awk script which we have. Now here, if you observe, we have taken initially the values and then we extract the key columns using $ones. For example, first is event, the second one is time, the third is node ID, right? The fourth one is level because we want AGT. Then we want packet type, maybe TCP or UDP, right? And thereafter the packet size means the data packet size. And thereafter what we are doing is we are actually trying to observe, we are printing it, the time and the throughput. So this is the formula of throughput, right? 1000, and then this is packet size and then the received. So received is the number of packets, right? And then we are multiplying it with the size of it. So every time we want to extract the packet which is received, which is data packet, which is TCP type, and then we increment it and then we end it. So this is the throughput script for generating the graphs for TCP especially. Now what we want to do is we want to run this awk file on our trace file. So how to do that? Awk -f throughput graph tcp.awk. We want to run it on 002 tcp.tr, right? And we want to save the outcome of whatever is extracted for every time the loop is executed, right? What we want to do is we want to store it in another data file. So we are creating a data file. So what is that? That is throughput graph 1. So this is the first data file for TCP throughput for us. So once we run it, let's see what is the content of throughput graph 1. Why you have to have a look at it? Because we have to know that it should not be empty. If there is not enough data or not proper data coming up, you should modify your awk script, or as and when required, maybe TCL as well. So now what we want to see is first column is our time. We have kept the 2 intervals, so it's obvious that it is storing at first and thereafter 3, 5, 7 because the interval is 2. You can change the interval as and when required as per the requirement. You know that we have been starting our traffic generation, actually packet transmission starts at 10 seconds. So therefore initially it is 0. And this is what is the throughput, right? So we can see the values are at times very heavy, 3000, and also maybe we will keep the values, the range of X and Y a bit higher. Okay. So till 97 time it is storing, because you know that 99 nothing was there. So that's how we know that the file is having a data. Now what we want to do is we want to plot the graph. For this graph, we have first of all created the first one for TCP, but let's hope that we also want to plot more than one graph. So if we want to plot more than one lines in the same graph, we may need more data files. One data file is not enough. So let us create the second data file for UDP. So for that we have a TCL file already created. So let's have a look. So again we go for ls*.tcl and it gives me these many, and we have the wireless to UDP.tcl. So here the difference is only in the type of traffic generation. All other things are same, so that we don't get confused much. The major difference is 002 UDP.tr, 002 UDP.name. So these are the two major difference. Otherwise the topology remains same. There we were observing 802.11g, here we are observing 802.11b. The only difference is that the data rate is slow, so that the two lines separates. You need not to do that. If you put it together, it will be mix and merge, and therefore we have separated it with the data rate. The node is getting generated here, and thereafter again we would like to change the position to be at 2. We have a UDP agent. So we have UDP agent and null agent. The way we had TCP agent and sync agent in the previous file, we have this too. And we are generating the CBR type of constant bitrate type of traffic. Once we have created, we can observe again the 10th second the traffic starts, and most of them ends before 100 seconds, right? Almost around 98. So this is the TCL file. Now what we want to do is, as we know, we want to now run the file. So wireless to udp.tcl, we run it. After it gets executed, we will get the trace file and name file. Right? We'll not get into the name file. It's just the visualization. What is our focus is TR files. So we'll have a look. Is there anything in the .tr file? So we had 002 udp.trace file. This checking is necessary. If we don't do it, what happens is many a times, if these files are empty, means our TCL is not generating our trace files properly, right? Logging is not done properly. Earlier we mentioned that this is the events and the timestamp, and thereafter we are interested in AGT, and thereafter the packet type and the packet size. So if you observe, mostly whenever there is a CBR traffic, its size is 230, which is a data type and which is mostly the AGT. So that's how we have to as and when our requirement is. You can edit the Awk scripts as and when required, but learn to modify the Awk scripts as per the parameter requirements. After this, what we want to do is we want to extract exactly two columns. The first one is time and the second one is throughput for UDP. To do that, what we will do, we need an Awk script. So we have an Awk script. Now for that, we should first of all have a look at the Awk script. So the Awk script UDP, let's have a look. So you see, I have also maintained the same format. What is the difference lies here is CBR, right? So if you don't want this AGT, you can modify it as and when the requirement is, right? So then this is the body. I need not to explain because the same is the code. The only difference is the type of packet we are observing. Now we'll run this Awk script on the trace file. So for doing that, we have the same formula. Awk script, you can use gawk as well, up to you. Throughput graph UDP awk. We want to run it on 002 udp.trace file, and the output has to be stored in another file, data file, where we are going to write throughput graph 2. And then we would like to know what is the content of it. It should not be empty. If it is empty, means our data is not properly absorbed. So this is the time, second one is the throughput. After this, if you see it's 97, means until the end it was executing, has not got stopped in between. So now we move ahead. We have both the files ready to generate the graphs. To generate the graph, we will be using the software Gnuplot. So what Gnuplot is an amazing tool. I have been using it for years for plotting the scientific graphs in my research papers. It has sufficed all my requirements, and you can observe a lot of information and learn a lot about Gnuplot using the Gnuplot documentation, right? So it's like a beautiful document of a book, but it really suffices enough of my requirements. For example, these are some of the types of graphs it generates. So plotting styles is something like you can plot the box types, you can plot many other types, like if you see, this is just the example of a jitter, right, using points. And then boxes, there are boxes, multiple options, lines, right, candlesticks, see. So all these options are there, circles, this all beautiful figures we can generate using the beautiful GNU plot. I'll not go much into the documentation. And here GNU plot. So how to set it? So I'll go with the very basic commands from. Suppose I want to set the terminal and I want to have a PNG, and maybe so type PNG no crop size is set, right? And the size of my PNG, because I did not give it, it is going to be 640 to 480, right? But I can also set it, set terminal, because many of times you have this requirement that when you write the PNG type, maybe you have to like use the EPS format. Then you can use EPS. If you want the another format like PDF format, then you can use PDF as well. So instead set terminal to PDF like that. And after that you may want to set the proper size. Few journals demand this, that you have a particular size of the image. Now we'll go ahead with the time format. So we set the time format %s, that is seconds. Then I put the range, so x I'm going to plot time in x range. So I know that I ran my simulator for 100 seconds, so I put it from 0 to 100. Then I put y range. Now y range I'm going to plot the throughput, that is the second column, so that I know that the ranges are more than 3000, so let us keep it to 5000. And thereafter we can set the labels. So set x labels. I know that x is time in seconds, right? And set y label, that is throughput, that is in kbps, right? And after that we set also the grids, and then we can set the style of data as lines, points, or lines or points, or anything you want, box, the way you want it. There are multiple options like that. Once all this setting is done, what we want to do is we want to set the graph output. So then comes the plot, is very important. So plot, what is the data file? So the data file name is throughput graph 1, right? Using the first and second column. So 1:2. If there are multiple columns, you can plot 1 with the 3, 1 with the 5, likewise. And then I want to give the title as TCP throughput. Okay. And I want the line LC or LT. Line text RGB is the full form of RGB color. And first one I want first to be blue. Okay. And I can also parallelly plot the second graph. So the second graph I should have plot, this is second graph, right? So we'll plot both of them together, one by one. So if you don't want multiple lines, you can stop here and then it will generate the graph. We have forgotten few things, that we want to set the size of it, that is 800 by 800, as I mentioned earlier. Okay, so that is what is the size of PNG, and we want to set the output of it. In that case, we want our output set output as result.png. Now we know what file it will be storing our output. Now we will plot the file. So once we have done all these things, we plot, and then second file. So then comes the second data file, that is throughput graph 2 using 1:2, right? First and second column. Title, we want UDP throughput. Okay. LT RGB red. As of now, because we are writing in the same line, is giving this error, so it is going to execute. Now what we have is, we have our file ready, ls star.png, and we have result.png, right? So let's have a look at the shell script which we have created that has the file content or the setting contents for gnuplot. So that we have here graph generation. So if you observe, we have a set terminal png, same things which we did, set output result.png, and then x range, and then y label, and then auto scale, and then y range, and then y label. So like x and y, range and label. We set it green so that it's easy to compare that where does the actual data points to x and y axis. Set the data style to lines points. You can put it box, you can put it the way you want it. And then we plot both the files, that is throughput graph 1 using first column and second column title. We have given it nan. It's up to you what you want. It's just for the example I have taken it. You can put it the way you want it. We keep it general, TCP throughput and UDP throughput. And then we give it first of all the blue line and then the red line. So there will be two lines in the graph so that we can compare. And then we save it. And then this is what we want to run it. So to run it, what we have to do is simply we have to write gnuplot. But instead of entering, we will run the script directly. So our script is graphgen.shell script. So you can create this file using gedit graphgen.sh and then write the content. Now let's see if we have the result file ready. So yeah, we have it here, and then we have this file ready with us. Now we can use this throughput in kbps, right? And then time in seconds, and this is exactly the graphs we see in the systematic scientific reports. You can have multiple such reports, such graphs, network parameters, by just playing around the TCL, TR, Awk, and the GNU shell scripts. And that's it. I think this is enough for all of you to create scientific graphs. I recommend you explore the documentation of gnuplot. It's amazing, and you can generate amazing graphs using gnuplot. Thank you.